Okay, this new chapter is on mathematical induction. Okay, this is the last of your series, last installment of your series and sequences. Okay, so for this topic, we're actually doing a proof of results, usually seen in series and sequences, okay, using something like we call the domino effect. Okay, I leave it to you to read the introduction. I'll just run through one question before we come to the steps required to handle such a question. Okay, so for this question, they say prove by mathematical induction this result. Okay, so there is a left hand side and the right hand side. Okay, there's a left hand side and right hand side of this result that we are supposed to prove. So how to handle this is, first step, we need to state the proposition. This is step number one. State the proposition. The proposition is what we are expected to prove. Okay, we're expected to prove this result. Summation, okay, equals to some result down here. Okay, so how to begin is we consider the first case. So how to know what is the first case? We look at the bottom. So first case, consider P1. So the left hand side of P1, all I need to do is to do a summation from 1 to 1. Okay, and the result is basically just half, if you can still remember your summation rules. On the right hand side, all you need to do is to replace your n by 1, and you're going to show that it's also equals to half. So what you have shown is that the left hand side is equals to the right hand side. So what it means is that you have actually proven to me that P1 is actually true. Okay, then I need to assume, okay, I'm going to get an assumption, assume that PK, okay, just now is P1, now it's PK. PK is true for some value of K where K is greater than or equals to 1. Okay, and then this is what I'm going to assume to be true. So basically it looks exactly the same. The only difference is just now we have Pn, now it becomes Pk. So result n becomes K. N becomes K. So all you need to do is do some simple replacement. Okay, and then I want to show that Pk plus 1 is also true. Okay, my objective is to show that Pk plus 1 is also true. So if Pk plus 1 is also true, the right hand side is equals to this result. Okay, so this is basically the right hand side. I always start with the right hand side. I need to see what I'm supposed to prove. Okay, then I go around and try to prove my left hand side. So this is my left hand side. Okay, this is my left hand side. So left hand side of Pk plus 1 will look like this. Based on your rules of summation, notice this is K plus 1. I downgrade it to K. What it means is that I do a summation from 1 to K plus the next term. This is actually the next term, or simply the, in this case, is the K plus 1th term. Okay, how to get the K plus 1 term? Replace R by K plus 1. Replace R by K plus 1. Okay, and that is what you have. Next, what you're supposed to do is to look at this thing now. Focus on this bracket. Okay, summation of 1 to K. This result in yellow is basically this result that I have made an assumption. Okay, it's basically this result down here. Okay, so if I'm gonna replace, okay, the section in yellow with this section, okay, which I have made that assumption. So this yellow section has been replaced with this result which I have previously. Then adding on to the next term. Okay, the next term is what we have down here. Okay, copying down. What I do next is to make the denominator common, keeping the 1 as it is. Okay, handle these two terms, make the denominator common, combine them, you actually realize that it's equals to this, and which is equals to the right hand side of Pk plus 1. So what you have actually done is that you have proven that the left hand side of Pk plus 1 is equivalent to the right hand side of Pk plus 1. So what you again, based on this proof, we have actually proven that pk plus 1. If I have assumed pk plus 1 is true, then if I assume pk to be true, then pk plus 1 is also true. Okay, then finally I have this concluding statement. Since my p1 I've already proven it to be true, and then I have proven that pk is also true, then similarly on top I've proven that pk plus 1 is true. Okay, so actually it's like a domino effect. Since p1 is true, okay, so replace pk by p1, then it will imply that p2 is true. If I put k equals to 2, p2 is true, it will imply p3 is 2, so on and so forth. This is when the domino effect come in. Okay, so finally you can make a conclusion that by mathematical induction, Pn is true for all positive integers of n. Okay, so this is where the domino effect kicks in.